Okay, so here looking at concave up, concave down, and inflection points. So we first take our first derivative. X to the first is going to go to be a linear term. Bring down the 3, get negative 3/2 x squared. 2 times 1/2. So we get 2x, and then the plus 2/5 is going to go to 0. Now, before I take the second derivative, I always simplify. So this first derivative, the 2/3 cannot simplify, the 3/2 x squared cannot simplify, but these 2's can cross out, so I like to cross those out. Okay. Then I'm going to take my second derivative. So the 2/3 is a standalone constant, so that's going to go to 0. And then the negative 3/2 times 2x, and then minus our x to the first will just go to 1. And then those 2's are going to cross out and give us f double prime equals negative 3x minus 1. Now, the thing that you have to remember with this concavity test is that you are working exclusively with the second derivative. You're setting the second derivative equal to 0 or does not exist, and then drawing your derivative number line for the second derivative. Okay, so I'll just write second derivative there because my little prime didn't work out too well there. Okay, all right, so we're going to ignore all this other stuff about f prime and f double prime simplification. We just look at f double prime and set that equal to 0. That's a one variable equation, so we'll just undo PIMDES by adding 1 to both sides and then dividing by the negative 3. So that gives us x is equal to negative 1/3. And that is our possible inflection point. We put that possible inflection point down on the number line. We're going to plug into the second derivative. Again, all of our work is done exclusively with the second derivative. So I'm going to plug in a number to the left of negative 1/3. So maybe I plug in negative 1 into that second derivative. So that gives us negative 3 times negative 1 minus 1. So that gives us positive 3 minus 1. So that gives us a positive. Okay, so that first interval is going to be a positive. Now, that positive, because it's the second derivative, tells us it's concave up. Then from negative 1/3 to infinity, I might plug in 0. So I have negative 3 times 0 minus 1. That gives us 0 minus 1. So that gives us a negative. That negative, because it's the second derivative, tells us it's concave down. Now, to get our answer format, we are going to say it's concave up from negative infinity to negative 1/3. It's concave down from negative 1/3 to infinity. So those would be the intervals on which it's concave up, concave down. Then when it says inflection point, you need to see a first derivative existing. And our first derivative here is going to exist for all real numbers because, again, there's no denominator, no square root, no natural log. And the key thing you're looking for, especially in this class, is that concavity change. And we do see a concavity change. So because we have that concavity change and the first derivative existed, first derivative exists, okay, we are going to have an inflection point. Our inflection point is going to happen at negative 1/3. And then to find that y value, because this is a point, we are going to plug into the original function to find the point. Okay, so we're going to take our x comma y, and we're going to have our negative 1/3 and plug it into our original function. So that's going to be the 2/3 x minus 1/2 x to the third minus 1/2 x squared plus 2/5. Now let's see if we can type this in on our calculator correctly, because that's going to be a bit of a challenge, everybody. But we're up for the challenge. Okay, so what you need to do is you need to make sure you put parentheses around the 2 divided by 3, because that whole fraction needs to get multiplied by the x of negative 1/3. Okay, then you'll have minus, and then the 1/2, so 0.5, and then, or let me write it as a fraction. So I'm going to put parentheses around that whole fraction, 1 divided by 2, and then parentheses, and for that x, I'm going to plug in the negative 1 divided by 3, raise it to the third, minus, parentheses around the fraction, parentheses around the x to the negative 1/3 plugged in squared plus parentheses around the 2/5. So the thing that I'm trying to show here is you really want to put the parentheses around the fraction to make sure that all of that fraction gets multiplied by all of the x fraction. And I'm just going to make sure that I did that correctly. Hopefully I did that correctly. And then you can hit that math frac button, number one fraction, to convert it into the fraction if possible. So math frac, and that gives us 19 over 135. So our inflection point is going to be negative 1/3, comma 19 over 135.